Okay, so today uh, I'm gonna participate in a Leetcode contest. Let me record that one. So it started 4 minutes ago. We take okay, register now, register. Okay, sort matrix diagonals, counts of strings. Okay. Oh, it starts with a medium already. So two mediums, two hearts. Okay. Okay. We return matrix such as those diagonals in the bottom left triangle, including the diagonal sorted in the non-increasing order. 3, 2, what? Diagonals in the bottom left. Okay, bottom left 4. Then I have 1, 6, 8. Non-increasing. Okay, so for every so I should like do the diagonals. What? No, that. Can you go play piano? Then Roblox. Oh, not Roblox. I already. Bring me the laptop.
No, I have 40 minutes left, but you have to give me time after. I'll do one.
Okay, so 4 and I. So for the I gonna be the diagonal I equals 0. I let's say have int n equal grid length, and then for I equal 0, I less than n, I plus plus, and then the diagonal gonna be so j. What gonna be the j? J minus initially it's gonna be so this one gonna be the diagonal j let's say diagonal d less than n d plus plus, and then
Look how much I was doing today. Look. I did more than 1 hour. Can I take a break?
no, do one less and then do the break. Okay, so diagonal gonna be start from 0, and then in this diagonal the I gonna change from, so the j gonna change from 0, usually does from 0 in the lower triangle to the to n. So I gonna be how to do the diagonals. Should they be globally sorted or just by diagonal?
So I have 16.
Okay, so it's like every diagonal.
Okay, 7. So how many does more? I collect 16.
for I is equal D, I less than n, I plus plus, and then j gonna be for j into j equals 0, j less than d, plus or equal d, j plus plus. Oh, like no, the j in this case gonna be I in j gonna be I minus d. Yeah, and then have initially I will have the int, say integer, say array list. Let's say int r equals new int. Then here gonna be the length n minus d, and then a j gonna be equal grid ij, and then I'm gonna have arrays sort. Actually, it's hard to sort int Java, int array Java sort. So array sort, just array sort, okay. Array sort A, and it should be decreasing. Decreasing, non-increasing. Edit, okay. Something like that. A, and then I'll put it back. Grid ij gonna be aj, and then for the above triangle, top right triangle, I'm gonna have int d equal 1, d less than n, d plus plus, and then int a is equal new int n minus d, and then I'm gonna have the similar one condition. Probably I can optimize it. So here gonna be so here gonna be diagonal. So here the j gonna change. So the j gonna be from j from d to n, j plus plus, and then in this case I is equal j minus d, j minus d, and then I grid ij sort and do the same manipulation, and then reversed. Okay, let's run. No, erase sort. Okay. What if I gonna do this? And here and here. So is it a right one? 823 967 451. Okay, the next one 0 1 1 2 2 1 1 0, and the last one 1 1. Okay, the condition. Okay, submit. Next one, assign the elements to groups with constraints. If you give integer groups, where groups represent the size of each group.
So, Martin Coxter. Martin collects. Martin collects dirt. Sorry.
You are given an integer array groups where groups I represent the size of the ith group. Okay. You're also given an integer array element. Your task is to assign one element to each group based on the following rules. An element j can be assigned to group I if a group psi is divisible by elements j. Okay, so in this case, I have groups and elements, and then so let me make it bigger. You are given in integer array groups where groups present the task one element to each group based on the following rules. Element j can be assigned to group I if groups I if there are multiple elements can be assigned to the element with smallest index j. So I have if the element j, if the groups, so groups I is divisible by element j, if 8 is divisible by 4, what's the constraints for this one? Oh no, that's groups length, element length to the power of 5. Okay, so it's a little bit hard. Let me figure that out by drawing this task. So if I have this array 8, 4, 3, 2, 4, this is groups and elements 4, 2. So 8 is divisible by 4. That's why I assign 0 index here to the result. 4 is divisible by 4, so I assign 0. 3 is not divisible, so it's like kept -1. 4 is 2 is not divisible by 4, so I'll keep it -1. And then 4 is divisible by 4. This one can be 0. So next one I'll need to fill up for the 2. 2 is 8 is divisible by 2, but the problem is the index is 1, so I challenge this index, but I cannot because like this index, a new index is higher that's already filled up and it's like not empty, so I'll skip. And then 4 is divisible by 2, but again I'll skip it. 3 is not divisible by 2, so I don't keep it, so I just don't fill it. And 2 is divisible by 2, so I fill up with 1. and then again 4 is divisible by 2, but it has already been filled. So it seems like so this group length can be 10 to the power of 4, and the element length is 10 to the power of 4, even 5, 10 to the power of 5, and this one 10 to the power of 5. So it seems like must be some easy trick how to figure this out, how to figure out the solution. So 10 to the power of 5. If I gonna like do this iteratively, I'm gonna check for it's gonna be 10 to the power of 10, because like I need to check like every index here. I check if it's divisible, if this number is divisible by, so like I have like n squared solution. For every element I check a group if it's divisible, and then I can like optimize like some don't go like to the indexes that already been filled, but I also can fill up the priority queue. But the problem with the priority queue is like depends like whatever like element is current. So if I do the for every kind of number, I need to quickly kind of figure out what the smallest index in elements. How I can do that? That's I can definitely like order this one array of elements like sorted 2 and 4, and kind of like find the square root with a binary search. square root of like a group. Must be easy problem, but I don't see a clear solution here. What's the already? It's already kind of a lot of people submitted.
I don't care about Disney. I want to exit. Dad, I already did 87 minutes.
So what?
I now want to play Roblox.
Okay,
I'm
go
tired.
play. Go play. So finding the small like the smallest index divisor in this array, in the element array. Also the index matters. So if I take this one value and check somehow where are the multiples of this one in the group, how I can do that efficiently? So if I'm gonna record somewhere all divisors of 8 in a hash map, and then all divisors of 4 in a hash map, let's say for the 8 I'll go save 2, 4, 8, and then I'm gonna save, this is gonna be 0, 0, 0, and then for the 4 it's gonna be also 1 and 2, and for the 3 it's gonna be, say 3, it's gonna be 1, and okay, so for the 3 it's gonna be 1, 1, 0, 1, 2, and then for the 3 it's gonna be 2, and for the 2 maybe 3, and then 3, and for the 4 it's gonna be 4, 4, and 4 here. What?
I only have 5 minutes now because I did so much work.
So what? For how long do you want?
I don't know, 1 hour.
That is too much. Here you are.
I did more than 1 hour of already.
So for the 1 it's gonna be 0, 1, 2, 3, 4, and for the 2 it's gonna be 0, 1, 3, 4, 0, 1, 3, 4. For the 4 it's gonna be 0, 1, 4. For the 8 it's gonna be 0, and for the 3 it's gonna be, so like if I gonna have already 0, no, if I'm gonna process this one, so oh no, that I need 8, 4, 3, 2, 4, 0, 1, 2, 3, 4. And then I have 2 and 4. So divisors, so for the 8 I have, so for the 8 I have divisors 2, 4, and then 8, and then it's gonna be for this one and 1 actually, 0, 4, 0, 8, 0. So if I'm gonna jump on a number 2, and then I'll need to, let's say, okay, whatever. For the 4 I'll have 1, and then 2, 2, 1, and then 4, 1. For the 3 I have 2, then 3 here, 2, and then for the 2 I have 4, well 3, 3, and then for the 4 I'm gonna have 4, 4, 4. So next what I'm gonna do, like for the 2, I need to update, so the index of 2 is 0, so I need to update all these indexes and kind of remove them from all other hash maps, from all other occurrences here and here, so I don't do that twice. How I can do that? Discard all those values. Might be hard. So the space here is so definitely I can go up to the value itself. So the question is how I can efficiently update this map so that I don't keep visiting. So like again, for the 2 I update index, so I have a result 0, 1, 2, 3, 4, and then yeah, for the 2 I update 0, 0, 0, 0. Yes or no? 2 is divisible. It's 4. Okay, so 4 starting from 4. 4 and 2. 4 and 2. And in this case 4 update 4 gonna be 0, 0 and 0 here, and then for the 2 it's gonna be so I'm gonna start again going to for all these positions, and then I will do what? I'll see that they already updated with not with kind of repopulated. So let me find that algorithm. Efficiently getting on dividers and given number. So it's gonna be 10 to the power of 5. So we're gonna go for, we'll have this hash map integer, and then gonna be hash set integer. and then here I have with this. So it's just indexes. So let's say there must be some structure that I don't know. So hash set, or like array list, let's say array list, and then gives equals new hash map, and then for int, say int n equals g equals groups length, and then for int I 0 I less than g I plus plus, and then for int j equal, so like I'll add divs put like get or default groups I, and then the index new get a default new hash playlist integer, and then that's gonna be array list integer, then a, and then for int j when j equals 0, let's check what we have here. Not that many. Okay. When j is equal 0, and I'm gonna put the a put I or add I. What here I have the indexes of what? Oh, of indexes of current groups. Okay. For add I, and then for I need to find all the divisors. Okay, all the int val equals groups I, and then here all, and then for j is equals 1, j less than math sqrt of all, and here integer, and then less or equal, and then j plus plus, and then I wanna get this, get a default. If val 1 by j is equal 0, I want to do this. Div, so I want this divs put j, and then j, like I equals div get j, and then I wanna add that a add divs put val a, and then a add I, and then divs put j I a j a, and then the same for the reverse val over j, something like that. And then this one gonna be this way, and then I'm gonna do the int res equals new int n, then for int I equals 0 I less than n I plus plus, and then I'm gonna go res I is equal -1, and then for int I is equal 0 I less than group elements length, then I plus plus, and then I wanna do if divs get, okay, so I wanna have this array list get for the what element size, so int val equals elements I, and for the val I wanna get, and if a is equal null I wanna continue, otherwise for int index in a I wanna go if res index equals -1, res index gonna be I, and then return I, return res. No. So int n gonna be, so here gonna be g, time limit exceeded as it was expected. So this one, the most issues that occurred, I get this double for loop. This one for, and this one for. Okay. Um, must be additional step required somewhere. So the most annoying thing is that when I need to basically somehow remove this indexes, from the next iterations, from all following so like this one, so if the index already filled, so if I'm trying to fill the index if I'm trying to fill the index for the result, I should find how many, like what the first so here I should find all the elements fast that have 4 as a divisor. For as a divisor. Okay, let me read the program because I don't know how to do that. You are given an array of points of size n and integer m. It must be a super easy problem. It is. There are a lot of people that solve this problem.
It was manager. I'm going to rob Percy. Let me just check on mine first.
So this problem is similar to what I solved, like probably, I don't remember how long a time ago. How to figure out if the number is divisible by a digit. Long string divisible by digit. What was that? It was some of the problems. Some of the problems that were on a contest. Some time ago. No, I cannot find that. Interesting. It was one of the problems on the contest. I remember. Okay, so like the divisibility by a digit of really long string, and then I need to have a substring. For some cases, it will involve like reading the whole number, but for the some cases, like if the number is like so if number ends by 1, so it's gonna be 4 and I equals 0, I less than. So let's say int n equals s length, and then I less than n, I plus plus, and then let's say long s equals 0, and then if s char at I is equal, let's say 1, so it's gonna be res plus equal s like I plus 1. So all substrings that end by 1 are divisible by that one. So 1 divisible by 1. So if I have like 2, so like the divisibility by 2, and then I need to figure out what the divisibility by 9, and like for every kind of digit I need to figure out like what the divisibility pattern, and then for some of them it just like it gives like it's if s char at I is equal, let's say 5, it's gonna be the same res plus equal I plus 1. So if it's like by 0, zero, 1, 1, 2, okay, it's also divisibility by themselves. So 1 also things that end with 1 here gonna be 3. So 1, no, 1, 3, then here 1, 2, 1, 2, 3, 4, 5. So for this string it's gonna be so it's gonna be 1 plus 3 plus 5 plus 7 plus 9. So it's gonna be 10, 25, yeah, 25. I don't know. I don't wanna solve this problem. Let's move to other one. This one would be interesting to solve, but I have no idea how to do that right now. So this one just involves like studying divisibility patterns, like for the every digit, like by 0, by 1, by 2, by 3, by 4, and so on and so forth. And then checking if can be calculated like in more or less, I would say, constant time. Because for the every ending digits I need to figure out like, okay, so the 7 divisibility by 7. So by 1. So by 2 it's gonna be the same. So yeah, this one was, I guess, something like that. The divisibility rule. So by 2 it need to be 0. So gonna be pretty much all substrings. So for the if so by 0 it should be like, should be fine, I guess. And then there is no divisibility by 0. Yeah, okay. So there is no line that ends by 0. So if as char at I is equal 0, then res continue. If it's equal 1, then all substrings that end with 1 should be added. And then if it ends by 2 at I equals 2, then also res plus equal I plus, okay, so I plus 1. And then if s char at I is equals 3, then the sum of the digits must be divisible by 3. So I need to go like backward and for every substring calculate the sum of digits. So long sum divisible by 3 equals 0, and then I need to go sum, or just digits sum, and then sum was equal s char. Okay, so char ch equal as char at I, and then char minus 0, and then here int, and then if char is equal 0, it's gonna be this one. If char is equal, okay, this one, and then char is equal this one, gonna be this one, and then if char is equal 3, then sum of the digits must be divisible by 3. So I need to get all the substrings that end with 3 and check if they are how many of them are divisible by 3. So like should be like just remainders, yeah. So I should work with remainders, so they might be like remainders for 0, remainders for 1, and the remainders for like 2, because it's like by modular, and so for the 3 it's difficult right now. For the 4, so to do, for the 3 to do, for the 4 it will be something like last 2 should be divisible by if okay, so let's say sum equals s char, so char minus 0, then int plus I minus 1 greater or equal 0, then my s char at I minus 1 minus 0, then it's gonna be or 0 int, and then if sum divisible by 4, then I'm gonna have this res plus equal just I, and then if character minus 0, and then integer. If it is divisible by 4, then res plus. So by 5, it's easy. So like it definitely ends. So like it's gonna be res plus 1. And then if char is equal to 5, so I'm gonna have again res plus equal I plus 1, and then if char is equal to 6, so what's the divisibility by 6? By 2 and 3. Okay, so it's again gonna be res plus equal 1. So if char is equal 7, that one is a tricky one. So 7 last 3 digits must be divisible by 8. Some digits must be divisible by 9. So like the problem is like with 3, 9 and 7 and 8. With 8 I can fix it with something like if char is equal 8, I can check if I is greater than so it's definitely, so I should do the last 3 digits if it's possible. Let's let okay, int sum equals char and this and that, and then plus another one plus I minus 2, and then if sum is divisible by 8, then res plus equal I plus 1. And then for the 9, I thought like I have a gap here for 3, for 7, and for the 9. If char is equal 9, right? And if char is equal 7, and if char is equal 3. So the yes, the idea is to calculate the sums of the substrings and kind of have the, let's say, counter, so for the remainder 0, for the remainder 1, and for the remainder 2, how many substrings are there that have like sum as the remainder of 0, sum as the remainder of 1 by if I do mod 3, and sum as the remainder of 2. So let's say initially I have like, let's say 3, and then let's say I have like remainder, like number of substrings that has like a remainder of 0, it's like 1, and then I'll have the, let's say 3 and 1, and then now number of substrings that I have as remainder of 1 is gonna be 1, and then all that's remaining I need to add like, so this one moves to this one, so this one becomes 2, basically 2, and 2 becomes 0, the number we had, and whatever we had for 1 becomes like 2. So this one becomes 2, and let's say we have something like 1 again. Oh, like, no, like, say we have like 2, remainder 2. In this case, 2 becomes 1, and 2 plus 2 and remainder, so like this one becomes 3 also. 3. There are 3 substrings that have a remainder of that sum, so there are like 1 substring, 2 substring, then this one, and then this one. So there are total 1, 2, 3, 4, 5 substrings. So initially, let's do that again. 0, 1, 2 remainders, and then I have this rolling sum, and that's, let's say our sequence starts with 3. So we have like number of subsequences that that have the remainder sum equals 0, or like mod 3 0. So this one is 1. So let's say we increase like add the element to the sequence of, let's say 1. So now number of subsequences here that ends with 1, I need to, or that has like mod 1. So I need to check, like add 1 here, like plus 1 here, and then for all these remainders I need to move them. So this one becomes 1 here, like, so this one becomes 2. Let's say we have like 3 now. So the sum remainder remains like this one remains 2, and this one becomes like 1. And then let's say we add like 2, and then it means that I need to add 1 here, and then this one moves to this one to 1, this one moves to here, 2 plus 1. So and kind of this operation is like constant space, and that one can be done also for 9. Like, but the group's gonna be 0, 1, 2, 3, 4, 5, 6, 7, and then 8. And we are only interested in like by the end, like in how many subsequences we have that have like that have like some divisible by 3, and in this case divisible by 9. So only on this frequency. But I need to maintain all this to calculate like almost in a constant time. how many subsequences that end with the current one have like are divisible by either 3 like here, or like by 9 like here. So the only issue is remaining is with 7. 7 is a tricky one. Subtracting 9 times the last digit from the rest gives okay, this one is difficult because I need to maintain this sum. 3 times the first digit to the next, and then writing the rest gives a multiple of 7. So I should maintain somehow the rest. This one is weird. Multiply each digit from the right to left by the digit in the corresponding position in the pattern. So I should recalculate this for the every n. No, it doesn't work for me here. Yeah, the 7 is the most tricky one. Yeah, I guess that's all time. I ran out of time. So that's it. I'm gonna call that a day.